Ice floating on water feels completely normal. We see it in drinks, lakes, and oceans all the time. But if you stop and think about it, something about it doesn't quite make sense. Most solid objects sink in their own liquid. Molten metal sinks in liquid metal. Liquid wax sinks in melted wax. So why does frozen water float on liquid water? The answer lies in a rare and unusual property of water itself. To understand why ice floats, we need to talk about density. Density describes how much mass is packed into a given amount of space. Objects that are more dense than the liquid they're in will sink. Objects that are less dense will float. For most substances, freezing makes them more dense. As temperature drops, molecules slow down and pack closer together. That increased density is why solids usually sink. But water behaves differently. Water is one of the very few substances on Earth that expands when it freezes. Instead of packing more tightly, water molecules spread out as they turn into ice. This expansion makes ice less dense than liquid water, and that difference in density is why ice floats. The reason water behaves this way comes down to its molecular structure. A water molecule is made of one oxygen atom and two hydrogen atoms. This arrangement gives water a slight electrical charge imbalance. That imbalance causes water molecules to attract each other through what are called hydrogen bonds. In liquid water, these hydrogen bonds are constantly forming and breaking. The molecules stay close together but remain flexible and mobile. As water cools, those bonds begin to organize. When water freezes, the molecules lock into a rigid structure. That structure forms a crystalline pattern with open spaces between molecules. Instead of collapsing inward, the molecules arrange themselves farther apart. This creates a solid that occupies more volume than the liquid it came from. Same mass, more space, lower density. Because ice is less dense than liquid water, it floats. And while that might seem like a small detail, it has enormous consequences. When ice floats, it forms a layer on the surface of lakes, rivers, and oceans. That surface ice acts as insulation. It slows the loss of heat from the water below. As a result, the water underneath remains liquid, even in freezing conditions. If ice sank instead, bodies of water would freeze from the bottom up. Over time, entire lakes could solidify completely. Aquatic life would struggle to survive seasonal freezes. Many ecosystems as we know them simply wouldn't exist. Floating ice helps stabilize temperatures. It protects living organisms. And it plays a major role in Earth's climate system. This same property explains another familiar phenomenon. Lakes and ponds freeze from the top down, not from the bottom up. Cold water near the surface becomes denser and sinks until it reaches about 4 degrees Celsius. Below that temperature, water begins to expand again. The colder water stays on top, eventually freezing into ice. Once ice forms, it remains at the surface. The water below stays liquid and relatively stable in temperature. This process repeats every winter in cold climates. And it all depends on water's unusual density behavior. This behavior is so important that scientists consider water to be a chemical anomaly. Most liquids do not behave this way. In fact, fewer than a dozen known substances expand when they freeze. Water is one of the most significant among them. The effects go far beyond ice cubes and frozen lakes. This property influences ocean circulation. It affects weather patterns. It shapes how heat moves around the planet. Even life itself depends on it. If water behaved like most other substances, Earth might look very different. Ice floating is not just a curiosity. It is a foundational feature of the environment we live in. So the next time you see ice floating in a glass of water, you're witnessing something rare, a physical exception, a molecular quirk, a simple observation that hides a remarkable chain of consequences. Ice floats because frozen water is less dense than liquid water. And water is one of the very few substances on Earth that behaves this way. A small difference at the molecular level, a massive impact on the world around us. This has been Questions Answered. If you've ever noticed another everyday phenomenon that made you stop and wonder, leave it in the comments. It might become a future video. And if you enjoy clear explanations of the world around you, consider subscribing. Thanks for watching.